Introduced to Australia almost 100 years ago, cane toads are an ugly as hell pest that have decimated large parts of this country. Now, a crack squad of toad killers has a bold plan to stop the amphibious a-holes from reaching the precious Pilbara.
Introduced to Australia almost 100 years ago, cane toads are an ugly as hell pest that have decimated large music parts of this country. Now, a crack squad of toad killers has a bold plan to stop the amphibious a-holes from reaching the precious Pilbara. A tiny ant in Australia is tearing apart cane toads. And someone finally caught the footage on camera. We are talking about an insect the size of a grain of rice taking down one of the most poisonous animals on the planet in broad daylight in seconds. For almost 100 red years, this country has watched snakes, crocodiles, and goannas die from a single bite of these toads. Nothing worked. Not fences, not traps, not gene editing. Then a researcher pointed a lens at the wrong patch of mud, hit record, music, and saw something that changes the entire war. Underground soldiers rising for decades. The story of the Australian outback has been a sad one. A continent that took millions of years to build its own strange ecosystem was slowly getting hollowed out by a single mistake. That mistake had a name, and you already know it. The cane toad. These things are so toxic that almost nothing can touch them without ending up dead in the dirt. They have glands behind their heads that ooze a milky white poison strong enough to stop a heart in minutes, and the toxins seep out through those pores onto the skin. You know, the way a dog attacks a piece of prey is generally to open its mouth and clog on the either side of it to crush the brain. So, they then get this liquid sticky toxin into the mouth. For most of Australia's native predators, biting a cane toad is the last decision they ever make. Then something shifted. Researchers in the Northern Territory were out near the water on a hot afternoon. The kind of day where the air shimmers off the mud and the only sound is the dry rasp of ant legs moving across fallen leaves. They were studying the banks of a small pond where thousands of baby toads were about to crawl out and start their lives. These tiny toads are about the size of a fingernail. They look almost harmless. Each one already carries enough poison to kill a small lizard. Native Australian animals have learned to give them a wide berth over the years. Instinct tells them not to touch the lumpy little newcomers. On this particular day, the scientists saw something nobody had ever recorded. A group of meat ants was doing the unthinkable. Instead of veering away from the baby toads, the ants were charging straight at them. Swarming, pouring out of the soil in numbers that did not look defensive. They were not protecting a nest. They were hunting. What stopped the researchers cold was the coordination. The ants did not just bite once and back off. They worked like a single organism, locking onto a toadlet from multiple sides and pulling it apart while it was still alive. You could see the toad's chest rising and falling, the white poison beating along its back in the sun, while ants the size of a grain of rice walked over its skin and kept biting. The meat ant is a very specific kind of insect that lives in massive colonies across the tropical north of Australia. They are tough. They are aggressive. They are the kind of ant you do not want to step on barefoot. Nobody had ever expected to see them taking down a vertebrate. Especially not one armed with a chemical weapon strong enough to end a python. When a meat ant clamps onto a baby toad, the toad does what its biology tells it to do. It freezes. It sits perfectly still and starts leaking poison through its skin. This trick has worked against everything else in Australia for almost 100 years. A snake takes one bite, tastes the toxin, and either spits the toad out or dies trying. Meat ants are immune. Their bodies do not have the same kind of heart and bloodstream that the toad's poison is built to attack. So, while the toad sits there waiting for its attacker to drop dead, the ants just keep going. It is a total mismatch, and against all logic, the tiny insect wins every single time. Then came the number that made the entire field of invasion biology sit up. In some areas, the scientists found that meat ants were taking out up to 98% of the baby toads emerging from the water. 98%. That is not a side note. That is the kind of figure that can actually turn the tide of an invasion. The research team led by ecologists like George Ardfear and Rick Shine spent hours watching these battles play out at ground level. They saw ants grab toads by a leg and drag them, still kicking, back toward the colony. They watched scout ants run zigzag patterns along the mud and then bolt straight back to the nest the moment they made contact with a toadlet recruiting reinforcements within seconds. It was brutal. It was relentless. For a country that has spent generations losing this war, music, it was beautiful. The baby toads are most vulnerable in a very specific window. Right after they finish, changing from tadpoles into tiny toads, a stage scientists call the metamorph stage. They move slowly and tend to sit out in the open to warm up in the sun. The Gold Coast is expecting a visitor boom this Christmas, but no one wants these guests to stick around. They're baby cane toads. Have a look at this. This photo from Chugon has gone viral. In it, you can see hundreds, if not thousands of the pests. That same sun is what kicks the meat ants into high gear. Heat gives the ants energy. The ants use that energy to dismantle the toads one by one. Right at the moment, the toads are slowest and most exposed. It is almost too perfect. One detail from the field notes deserves to be said out loud because most people never hear it. When the researchers watched the ants up close, they noticed that the toadlets actually had time to react. A native frog the same size would have leapt away. A native lizard would have darted into the grass. The baby cane toads didn't either. Their entire defensive playbook is built around the one trick their ancestors brought over from South America. Sit still. Wait, let the poison do the work. In their original range, that strategy works against South American predators that have not adapted. In Australia, it is a death sentence delivered by an enemy the toad's biology has never seen before. The ants do not read the warning label. The poison they should fear does nothing to them. So, the toad sits and waits, and the ants disassemble it where it stands. This was just the start. The ants were not stumbling onto these toads by accident. They had a very specific way of finding them. A chemical signaling system that lets one scout pull an entire colony in the direction of fresh prey within minutes. Once the researchers understood how the ants were communicating, they realized they could hijack it. They could turn an opportunistic hunt into something closer to a coordinated strike on demand. That hijack is the part of the story almost nobody knows about, and I'm going to walk you through exactly how they pulled it off in Chapter 3. If you want to see where this whole investigation goes, hit subscribe right now so it pops up the next time I drop a video. Trust me, you do not want to miss what they actually used to weaponize the colonies. 100 Toad Army. To understand why this ant discovery is such a big deal, you have to rewind almost 100 years to the moment everything went wrong. It was 1935. Sugarcane farmers in Queensland were dealing with a beetle problem. The grubs were eating the roots of their cane, and the harvest was suffering. Someone somewhere had what felt like a brilliant idea. They would import a hungry South American toad that ate beetles in other parts of the world. So 102 cane toads were shipped in from Hawaii and released into the fields. That was the mistake. The toads did not even bother with the beetles. The beetles spent most of their time climbing high up the cane stalks. And the toads were heavy ground dwellers that could barely jump knee-high. The two species basically never met. The toads were not picky, though. They started eating absolutely everything else they could fit in their mouths. Native frogs, native lizards, beneficial insects, even small mammals. And they bred. They bred like nothing Australia had ever seen. Those original 102 animals turned into a population of more than 200 million. They spread west and south across the continent at nearly 40 m per year. A slow green tide rolling through Queensland into the Northern Territory, then into Western Australia, then pushing down into New South Wales. Entire ecosystems collapsed in their wake. Australia is essentially a giant ecological island. Its animals evolved in isolation for tens of millions of years. They never had to deal with a toad that could stop a heart with a single secretion. When a goanna or a chew or a freshwater crocodile spotted a cane toad, all it saw was a slow, plump, easy meal. Then it bit down and within minutes it was gone. In some regions, populations of native predators dropped by more than 90% in the years after the toads arrived. Northern quolls, beautiful spotted marsupials about the size of a kitten, were nearly wiped out across huge stretches of their range. Yellow spotted monitors, the giant goannas that used to bask along every river, vanished from places they had patrolled for thousands of years. Freshwater crocodiles in certain river systems took massive hits with population crashes so sharp that scientists could literally watch the wave of die-offs move across the map year. When the top predators disappeared, everything below them started to shift. Other pests boomed. Native prey species got hit from new angles. Feral cats and foxes, already a problem of their own, took advantage of the gap. The damage was not just about one toad eating one frog. It was an entire food web pulling apart at the seams. For decades, people tried everything to stop them. The government built toad-proof fences that stretched for hundreds of miles. Volunteers organized weekend toad-busting events where they would gather thousands of toads in a single night, often using buckets and headlamps and a kind of grim humor about the whole thing. Engineers designed special traps that mimicked toad calls to lure adults in. Scientists even floated ideas about gene editing, releasing modified toads that could not reproduce, or about training native predators to associate cane toad smell with nausea by feeding them small non-lethal doses first. Some of those programs actually worked on a small scale. Out in the bush, in the heat and the dust and the sheer scale of the continent, none of it scaled the way anyone needed it to. The country was hunting for a silver bullet, and all it kept finding was a louder echo of the same problem. The meat ant discovery was the first time anyone had documented a native Australian animal that could actually push back against the toads without any help from people. No genetic engineering, no imported predator, no million-dollar fence, just a bug that had been there the whole time, sitting in the dirt doing its job. The ants did not need to be trained. They did not need to be modified. They were already music there, waiting at the edge of the water for something soft to crawl past their nest. There was a catch nobody saw coming. The toads were spreading into regions where the meat ants were not very dense yet. The ants were winning the battles they were in. They just were not in enough places. That is where someone got an idea so simple it sounded ridiculous when they first said it out loud. Canned food solution. Just when it looked like the toads were going to win on sheer geography. The scientists came up with a plan that cost basically nothing. They knew the ants ate the baby toads. They knew the ants were not always present in big enough numbers right where the toads were emerging. So they asked a question that nobody had thought to ask. How do you get more ants to show up in exactly the right spot at exactly the right time? The answer was sitting in every supermarket in Australia. Cat food. They grabbed cheap cans of fish-based cat food. The kind that hits your nose from 10 feet away in the Australian heat. Oily and sharp and almost sour. They pried the lids back and placed the open cans along the muddy edges of ponds where baby toads were about to crawl out. That was the entire plan. It worked almost immediately. Within minutes of cracking those music cans open, the ground started moving. Meat ants poured in from every direction, following the scent like an army summoned out of the soil. They set up a perimeter around the water and they did not leave. This is where the story turns into a battlefield. When the tiny toads started crawling out of the pond, they did not find a quiet beach to start their lives. They found a wall of ants waiting for them. In areas where the scientists put out the cat food, the local ant density jumped by more than 4 times. The predation rate on baby toads went vertical. In some baited zones, nearly every single toadlet that left the water was killed before it could take more than a few hops. The water became a one-way trip. There is another layer to this that often gets lost in the headlines. The cat food does not just bring in ants. It changes how long the ants stay active in that exact area. Normally, a meat ant colony patrols, then retreats, then patrols again. A can of pungent fish protein keeps them stationed in one place for hours, sometimes longer. That overlap with the moment baby toads emerge is the whole trick. The bait does not have to kill the toads. It just has to keep the killers in the right place at the right time. There is a second piece of the puzzle that some of the researchers have been quietly working on for years. If you take the water away from cane toads, even briefly, they cannot survive. They absorb almost all their hydration through their skin. They do not drink the way mammals drink. So, if predators like meat ants can keep them away from the water's edge, even just push them a few hops back from the pond, the toads start drying out within hours. Heat, dehydration, and a perimeter of ants combine into something that no fence or trap has ever managed on its own. What makes this so quietly genius is the cost. We are talking about a few dollars worth of canned food protecting an entire pond. Compare that to the millions that have been poured into fences, traps, and lab research, and the math becomes almost funny. With cat food, researchers were able to defend specific high V-value areas, like national parks, wetlands near endangered quail populations, and even backyards and towns. Hands down, this turned out to be one of the most effective targeted defenses anyone has ever found against cane toads. There is a massive caveat, and it is important. This method only works on the babies. The full-grown adult cane toads are completely untouchable by ants. A mature cane toad can weigh up to 4 lbs and music is roughly the size of a dinner plate. Its skin is thick and leathery. Its poison reserves are massive, and it can easily walk away from an ant nest like it is shaking off rain. An ant trying to take down an adult toad would be like a person trying to bring down a moose with their teeth. It just is not going to happen. What the ants do is hit music, the next generation. They cut off the conveyor belt. A single female cane toad can lay between 8,000 and 30,000 eggs in one go. If even a small percentage of those tadpoles make it to adulthood, the population keeps exploding. If you destroy almost all of them at the metamorph stage, the math reverses. The adults still hop around. Music, are still a problem. Fewer and fewer young toads grow up